Dear distinguished guests, as the board member of the DEİK, Turkey, United Kingdom Business Council, I would like to thank you all for joining us today's webinar, Water Technologies in Agriculture and Cooperation Opportunities with the United Kingdom. It is an honor for me to be with you today. My name is Nurdan Erbuğ. I'm the founder and chairperson of Anadolu Hayvancılık and chairperson of DEİK Turkey-Canada Business Council, as well as the board member of DEİK Turkey United Kingdom Business Council. Water is a basic and crucial resource that underpins all economic, social, and environmental activity. Of the many ways in which water impacts humans, its intersection with agriculture is perhaps the most prevalent. The agri-food matrix accounts for 72% of freshwater use, and it empowers healthy communities, economies, and societies. As such, technological innovations that enable progressive stewardship, management, and water use led to both economic and social success. Therefore, resolving the challenges of the future requires an in-depth reconsideration of how water is managed in the agricultural sector and how it can be repositioned in the broader context of overall water resources management and water security. In today's webinar, we seize a chance to learn from each other's experience in new technologies. Before introducing our keynote speakers, I would like to inform you that Consul General Mr. Kenan Poleo cannot attend today due to an obligation, so he kindly sent a video recording of his message to our guests. I would like to give the floor to Mr. Osman Okyay, the chairperson of the Turkey-United Kingdom Business Council, to deliver his opening speech. Osman Bey, Başkanım, the floor is yours, please.
Thank you Nurdan. Mr. Sait Kocabay, General Manager of TİGEM, and dear guests. On behalf of the DEİK Turkey UK Business Council, I'm more than happy to welcome you to today's webinar. And let me begin by thanking Her Majesty's Consul General in Istanbul, Mr. Kenan Poleo. Although he won't be with us today, he will be joining with a video recording. And Mr. Sait Kocabay, board member and acting general manager of TİGEM, General Directorate of Agricultural Enterprises of Turkey, for taking the time out of their busy schedules to be with us today. And as DEİK Turkey UK Business Council, we are organizing our second webinar of the week. And irrigation and sustainable agriculture are key concepts for the future of humankind, as we will face steep challenges on how to feed a growing global population with even more limited resources and ever-changing dynamics. I hope our discussions today trigger opportunities that help us tackle those challenges. This webinar is the second one in 2021, where we dwell on the agriculture sector, an important area of cooperation between Turkey and the United Kingdom that bears enormous potential for growth. The possible expansion of FTA between our two countries to include a wider range of agricultural products would be an essential step to realize this potential. We hope companies who will present today will come to deepen their ties with their counterparts and partners from either Turkey or the United Kingdom. Lastly, I would like to wholeheartedly thank Ms. Nurdan Erbuğ, board member at DEİK Turkey UK Business Council and chairperson of Anadolu Hayvancılık, who has worked tirelessly for this event. Without her dedication and support provided by DEİK team, none of this would have been possible. And Nurdan Hanım, thank you very much once again, and back to you, please.
Thank you, Osman Bey. We appreciate your efforts to advance the bilateral trade relations between our countries. We will continue with Mr. Sait Kocabay, the General Manager and the Board Member of TİGEM. TİGEM is the General Directorate of Agricultural Enterprises under the Ministry of Agriculture and Forestry. Sait Bey, söz sizin lütfen.
Çok teşekkür ediyorum. Sayın Başkan, çok kıymetli katılımcılar, hepinizi Tarım İşletmeleri Genel Müdürlüğü adına selamlıyorum ve saygılarımı sunuyorum. Eğer ihtiyaç varsa Nurdan Hanım, buradan İngilizce olarak tercümeyle de gidebiliriz. Yoksa katılımcılar İngilizceye çevrilisi duyuruluyor mu acaba?
Duyuyorlar genelde.
Tamam. O zaman özellikle böyle önemli, hassas bir konuda bizlere söz verildiği için sizlere tekrar teşekkür ediyorum. Dünyada yaklaşık 2 yıldan bu tarafa yaşanan ve süreci devam eden COVID-19 salgını nedeniyle tüm ülkeler için gıda güvenliği ve güvenilirliği bir kat daha arttığı hepimizin malumları. Pandemi süreci devam ederken son yıllarda da dünyada iklim değişikliği hızı giderek artıyor ve çok anormal düzeyde beklenen iklim değişikliklerini halihazırda yaşıyoruz. Küresel ısınmaya dayalı son yıllarda ülkemizde etkisini daha da gösteren tarımsal kuraklık, bitkisel üretimi tehdit ediyor ve rekolta düşüşlerine neden oluyor. Bunlar hepimizin malumu olduğu gibi. Pandeminin yarattığı belirsizlik ve yaşanan tarımsal kuraklığa, gıda üretimine olan etkisinin asgari düzeye indirilmesi konusunda her türlü hem ülkesel hem de kurumsal olarak çalışmalarımızı sürdürüyoruz. Bu konuya geçmeden önce müsaadeniz olursa ben Tarım İşletmeleri Genel Müdürlüğü TİGEM hakkında genel bir bilgilendirme yapmak istiyorum. TİGEM, geçmişi 700 yıl öncesine dayanan Osmanlı İmparatorluğu döneminde çiftlikatı Hümayunlar eliyle ordunun gıda ve at ihtiyacını karşılamak amacıyla kurulmuş. Cumhuriyet döneminden itibaren bugüne kadar halihazırda ülkemizin ihtiyacı olan, açığı olan çeşitlerdeki sertifikalı tohumlukların ve üstün vasıflı damızlıkların üretilmesi ve yetiştiricilerimize, ülkemiz yetiştiricilerine buluşturulması ana ekseninde faaliyet gösteren bir kamu iktisadi devlet teşekkülü. Tamamı, sermayesinin tamamı devlete ait bir kuruluş. Tüzel kişiliğe sahip bir statüyle faaliyetlerimizi sürdürüyoruz. Faaliyetlerimizi ülkemiz geneline dağılmış 17 işletmemizde toplam 327 bin hektar arazi üzerinde sürdürüyoruz. Tabii ki birinci önemli ve öncelikli faaliyet konumuz sertifikalı tohum ve üstün vasıflı damızlık üretmek. Kısaca ben üretim alanlarıyla ilgili şöyle bir bilgi verecek olursam, hali hazırda 200 bin hektar tarla bitkileri üretimi, 7 bin hektarda bahçe bitkileri üretimi gerçekleştiriyoruz. Diğer otlakiyeler ve tarım dışı arazilerimizle birlikte az önce bahsettiğim gibi 327 bin hektar arazide biz faaliyetlerimizi sürdürüyoruz. Sertifikalı hububat tohumunda ülkemizin en büyüğü durumundayız. Her yıl ortalama 160 bin ton sertifikalı hububat tohumunu çiftçilerimizle buluşturuyoruz. Bu itibarla bu alanda Türkiye pazarının %30'luk bir payına sahibiz. Diğer taraftan yem bitkileri, endüstri bitkileri, sebze sertifikalı tohumlarını yine üreterek çiftçilerimizle buluşturuyoruz. Hayvancılık faaliyetlerimizle ilgili olarak 14 işletmemizde toplam 31 bin baş damızlık sığır varlığıyla 5 ırkta damızlık yetiştiriciliği faaliyetlerini sürdürüyoruz. Her yıl yetiştiricilerimize 3.000 ila 5.000 baş arasında damızlık satışını gerçekleştiriyoruz. Diğer taraftan 10 işletmemizde toplam 240 bin baş hayvan varlığı ile Toplam 13 ırkta damızlık, koyun ve keçi yetiştiriciliğini yapıyoruz. Her yıl ülkemiz yetiştiricilerine üstün vasıflı 25 ile 30 bin baş aralığında damızlıkların satışlarını gerçekleştiriyoruz. Diğer taraftan Osmanlı döneminden günümüze yadigar olan safkan Arap atlarımızı 3 işletmede yetiştiriciliğine devam ediyoruz. Bundaki esas amacımız miras değerindeki bu gen kaynaklarının korunması, yaşatılması, gelecek nesillere ulaştırılmasını hedefliyoruz. Diğer taraftan yine gen kaynaklarımızın korunması adına 2 işletmemizde akbaş ve kangal köpek yetiştiriciliğini yapıyoruz. Yine 2 işletmemizde Asya ceylanı yetiştiriciliğini yapıyoruz. Bir işletmemizde de Ankara tiftik keçisi yetiştiriciliğini devam ettiriyoruz. Bunun yanında en önemli konumuz, bugünkü toplantı gündemini oluşturan konu, tarla ve bahçe bitkileri üretimini yaptığımız toplam 211 bin hektar arazinin 94 bin hektarında sulu tarım uygulamasını yapıyoruz. Bu sulu tarım uygulamasının tamamı modern basınçlı sulama sistemleriyle gerçekleştiriyoruz. Sistemlerimiz sentripiyot, lineer, yarı sabit yağmurlama sistemi ve damla sulama sistemlerinden oluşuyor. Cazibe sulama alanımız kalmadı. Tamamen en son geçmiş yıllardaki yatırımlarla oraları basınçlı sulama sistemlerine dönüştürdük. Tabii ki bu küresel ısınma ve kuraklığa bağlı olarak artık ülkemizde özellikle Güneydoğu Anadolu bölgesi ve İç Anadolu bölgelerinde rantabil, sürdürülebilir bir tarım yapılması mümkün değil. Mevcut su kaynaklarımızın etkin, verimli kullanabilmesi amacıyla bu sulama sistemlerinin tamamını basınçlı sulama sistemlerine dönüştürmüş durumdayız. Hali hazırda bu 94 bin hektar sulu tarım arazimize ilave olarak 2021 yılında Ceylanpınar Tarım İşletmemizde 2000 hektar alanda sulu tarıma açılması konusunda yatırımlarımız devam ediyor. Kısmet olursa 2022 yılında da ilave 8500 hektarlık bir alanın sulu tarıma kazandırılmasıyla bu alandaki etkinliğimizi inşallah artırarak sürdürüyoruz. Tabii ki biz, Sayın Bakanımız sürekli olarak dile getiriyor. Biz su zengini bir ülke değiliz. Ama ülkemizin ihtiyaç duyduğu gıda üretiminin gerçekleştirilmesi için tabii ki ülkemiz topraklarının mutlaka suyla buluşturulması lazım. Bu kısıtlı imkanların daha fazla faydalanabilmesi için elbette ki bu sulama sisteminin kesinlikle azami tasarrufu sağlayacak şekilde basınçlı sulama sistemleriyle donatılması önemli, öncelikli. İnşallah yıllardan bu tarafa TİGEM her türlü üretimiyle ülkemiz tarım sektörüne öncülük yaptı. Bu konuda da öncülük yaptığını düşünüyoruz. İnşallah hayırlı olur diye ümit ediyoruz. Ben daha fazla zamanınızı almadan sözlerimi burada sonlandırmak istiyorum. Hepinize saygılar sunuyorum. Ancak TİGEM'le ilgili bir soru varsa katılımcılar tarafından tabii ki cevaplamaya hazırım.
Nurdan, mikrofonunuz kapalı.
Çok teşekkür ederiz Sayın Genel Müdürüm. Ben şahsen bu değerli TİGEM işletmelerin hemen hemen hepsinde bulundum. Bizim hepsi birer göz ağrımız. Thank you, Mr. Kocabay, for your precious words, both personally and as the Business Council. We put great significance on our collaboration with TİGEM. Hopefully, we can bring a valuable delegation to the United Kingdom soon, and we can host a British delegation in return. Now, let's hear Consul General Mr. Pallo before moving on to the presentations.
Hi everyone, I'm Kenan Palayo, Her Majesty's Trade Commissioner for Eastern Europe and Central Asia, and it's a great pleasure for me to join you today and open this forum in water technologies for agriculture. It's an extremely important subject for the future of our world. First of all, I would like to thank DEİK, Turkey's Foreign Economic Relations Board, and the UK-Turkey Business Council for hosting this really important event. And thank you also to my fellow speakers, the moderator, and especially to the Turkish UK companies who will talk about their expertise and technology in the agri-food and agri-tech space. Turkey and the UK enjoy a trading relationship that goes back for many, many years. And as Her Majesty's Trade Commissioner for Turkey and the region, I'm committed to growing our sizable trade even further. So how big is our bilateral trade? Well, it's really impressive. Total trade in goods and services between the UK and Turkey was worth £16.6 billion in the 4 quarters to the end of quarter 2, 2021. UK exports to Turkey amounted to 6.2 billion, while Turkish exports to the UK were worth 10.4 billion. Turkish exports to the UK are almost double its imports, so Turkey has an obvious advantage in its trade with the UK. Turkey is an agricultural powerhouse, so it's not surprising that agriculture and food products constitute an important element of Turkey's exports to the UK and to the world. A rapidly growing world population and more variable climate conditions mean new food production systems with less impact on the environment will be vital. As a global leader in agri-tech, the UK has much to offer to meet this challenge. We'll hear about some examples of these technologies and solutions shortly. The UK agri-tech industry has a long heritage in the design and manufacturing of machinery and equipment, and is viewed as scientifically progressive, technically advanced, and environmentally responsible. Our local DIT team would be happy to help connect interested parties in Turkey with UK suppliers. Once again, thank you for joining us today and have a really productive meeting. This event will be a forerunner for many others focusing on sustainable and climate-smart agriculture, on innovation that boosts yields and revenues, while also protecting soil health and reducing the need for imports. I also hope it will be a conduit between the UK and Turkish businesses, resulting in new partnership agreements. And so please do watch out for further events for this very important sector.
Thank you, Her Majesty, Consul General, Mr. Palayo. Before proceeding with our distinguished panelists, I would like to introduce my company, Anadolu Hayvancılık, very briefly. Our team are all veterinarians, animal scientists, and agricultural engineers. We are one of the major companies in the dairy industry of Turkey and the exclusive distributor for Genus PLC and ABS American Breeding Service. We are importing frozen bovine and ovine, semen and embryos, milk replacer, and other veterinary products. The biggest progressive farms and dairy processors are our key customers. The veterinarians visit the farms all over the country on a daily basis and genetically make the herds to maximize the reproduction. Now we proceed with our distinguished panelists. If you have any questions, please write your questions to Q&A part. Let's start with our first speaker, Mr. James Whitehead from Solar Water PLC. James Whitehead is an international executive with 10 years of general management experience and 25 years working with clients from around the world. His expertise in general management and commercial, business development and client relations, sales and marketing. Solar Water has developed an innovative green technology solution for converting seawater into fresh water using solar power. Solar water solution solves water scarcity while achieving zero carbon emissions. The floor is yours, Mr. Whitehead.
Thank you very much indeed. Thank you everybody for your attention today. I'm very pleased to introduce to you solar water. And we are here to solve water scarcity and the water crisis in a completely sustainable manner. Zero environmental impact with 100% carbon emission free solution at scale using only the concentrated power of the sun. We will all be very aware of the issue around water scarcity. I'm sure I don't need to talk about it in detail with you, and that global demand for fresh water is due to exceed supply by 40% by 2030. And particularly in the region in which Turkey exists, there is due to be extreme high water stress by 2040. Many of the existing solutions focus in on desalination. This is a significant growing current solution to the water crisis problem. But desalination comes with its own issues. And in general, this is based on the need for the high levels of energy intensity and the requirement to burn huge amounts of fossil fuels for that intense energy requirement. Globally, the desalination industry is putting out a carbon footprint of around 80 million tons of CO2. And this is due to triple to 220 tons per annum by 2040. Many of the solutions that counter this are on a very small scale, as you can see from this diagram here. In the top left-hand corner, they come on a small scale, often in a container form with solar panels, delivering perhaps only 500 cubic meters of water per day. And whilst the large desalination companies in the bottom right-hand corner are moving into renewable energy, they are not able to do it in totality. So solar water is able to deliver both the zero carbon emission solution, but also at a scale that would be suitable for Turkish agricultural project needs. Here is our solution. It's based around a solar dome with solar concentrators, as you can see in the top right-hand corner, and also heliostat mirrors, which are our two sources of thermal energy harnessing. The power of the sun is then conveyed into the dome, in which we then have a system that will then transfer seawater into fresh water. We can also use saline brackish water, which appears often in lakes. And I'm aware of this existence in some key areas within Turkey, where we will come on to talk about as well. So we're also able to convert saline brackish water from lakes into fresh water. Here are our solar concentrators. These are unique to solar water. They concentrate the sun's thermal energy like never before. They operate at a much higher efficiency rate versus standard PV, an efficiency rate of about 85% versus an efficiency rate of about 35% for traditional PV technologies. They also come with thermal storage capability. So this means that we can then run our solar powered system 24 hours a day, which helps us with then the volume and also with the cost and the price efficiency. Our technology is vetted by experts from around the world. Some of the top relevant institutes in Europe, in Asia, in the Middle East. And we are supported by a world-class ecosystem of technical associates, including the likes of Siemens and Bechtel. It's important to understand the mid-scale market nature of our solution. So this is neither at the very large mega project scale, which might be producing hundreds of thousands of cubic meters per day, but nor is it at the small scale, which might be producing a few hundred cubic meters per day. So we sit in the middle, and this solution is not only quicker to build and more agile, but it is also particularly relevant for agricultural projects, for particular urban development and industrial projects. Here is an example to convey the kinds of volumes that we are able to produce and the area of land that we would then require for those volumes. You can see on the left side here that at a smaller scale, we would be producing perhaps 8,000 cubic meters per day. This is 8 million liters per day, which is about 3 million cubic meters per annum, or 3 billion liters per annum. And for a plant producing this volume, we're looking at somewhere between 10 to 15 hectares of land. We can then scale our volume output, which then scales the amount of land that is required. And you can see how that then scales up to perhaps 28 million cubic meters per annum, or 80,000 cubic meters per day, which is 80 million liters. So we can have a conversation with a specific need and opportunity, and we can then tailor and customize our plant to the requirements for the volume of water needed, and also the requirements of the area of land that is available. We are, as always, incredibly grateful to the support and the endorsement that we have from the British government, from the Department of International Trade, and we are very well supported by them in Turkey and in other parts of the world. It's also important on the right-hand side to see that we come with the capital funding required for projects. So this means that we are able to then agree a build, operate, transfer, offtake agreement with a customer, no matter the size of the plant. Just last week, we announced, as hosted by the Department of International Trade, we announced that we now have funding of $200 million minimum for dome system projects. This here is a snapshot to give you an idea of potential pricing. Now, our pricing is obviously dependent on specific needs, specific project principles, but you can see that if we were to agree an offtake agreement with a certain level of solar radiation in an area, and these numbers are against the sort of level of solar radiation available in southern Turkey, then we can then produce around $1 per cubic meter or less, depending on what the volume requirement is. In general, the larger the volume requirement, the lower the price of the water. You can also see here what our CapEx and OpEx costs are, as there is the potential for customers to actually buy a plant off us. Usually people are agreeing a build, operate, transfer, offtake agreement with us over a 25 to 30 year period. Our solar water system requires the power of the sun, requires the thermal energy of the sun. And we have about 50 markets worldwide where this is applicable, where there is high enough levels of what we call DNI. And this is the solar irradiation level. You can see here that in Turkey, there is good opportunity, because we want to make sure that the DNI level is around 5 per day. And any color that is at least an orange color has that relative level of DNI. So you can see that with the exception of the north of Turkey, then the DNI levels are high enough. The second element that we require, obviously, is some saline water. So this is either going to come from the sea, in which case we will be looking at the southern and western coast, or it might come from lakes. And we are conscious and aware that, for example, there is the opportunity in an area like Tarsus, where there is agricultural projects and where there is this lake here, which has saline water in it, that we would be able to process. Also, the same again in, for example, Konya. And again, there is agricultural projects and there are lakes that have saline, brackish water in that we would be able to process. So, but we can have conversations with potential customers with needs anywhere in the south of Turkey. And we thank you very much indeed for your time and your attention. Here is a summary of Solar Water's solution. Thank you very much.
Thank you, Mr. Whitehead. Now let's move on to our second guest, Mr. Tanzer Bilgen from Doktar. Mr. Bilgen is an industrial engineer, and before Doktar, he worked for major business consultancy firms. Since its establishment in 2012, Doktar has made a significant impact on agricultural production with intensive use of information and data-driven decisions. Through remote sensing, machine learning, and the Internet of Things, Doktar has brought a new dimension to the agriculture. Would you please kindly begin to your presentation, Tanzer Bey?
Yes, sure. Thanks, Mrs. Erbuğ. And okay, hello everyone. I would like to start with actually our positioning, and basically would like to explain the value chain from data till execution of agricultural activities. Basically, from data collection, usually currently what's happening is most of the farmers are deciding on specific actions based on their experience of previous seasons. They just use their own observations and match them with their experience and act upon some corrective actions, like deciding on irrigation times, dates, or deciding on fertilization programs. Our company brings in the informed decisions based on data collected from soil, crop, and from climate. And at that point, we utilize machines actually. And the data collected from data collection till execution, there are 4 steps. And the first step is data collection. What do we collect? Like temperature data, soil moisture, or crops and the reflectance via satellites. This data does not have any meaning by themselves. For example, 35 degrees does not mean anything. When you combine that data with another data, with a couple of different data, for example, 35 degrees, you have a tomato crop, and the soil moisture is like 17%. It means like you have to irrigate, for example, okay? So the data consolidated in cloud platforms and turned into meaningful information. That information is processed further into recommendations, and those recommendations are based on type of needs of different stakeholders. For example, if you're a farmer, and if you are talking about an irrigation requirement, we will tell how much liters you are going to irrigate within a couple of days. But if you're a large-scale food processor and you run some contract farming corporations, and we are monitoring 1,000 different fields, we process that data not in terms of irrigation requirement amount, but number of under-irrigated farms in your contracted system. So based on that data, you may have different actions, okay? And the 4th step is the actually, once we provide the recommendations, the 4th step is the execution. The first 3 steps, data collection, processing them into information and recommendations, are done by machines actually. They are fully automated. So we collect data via satellites or climate sensors, IoT devices, or some digital soil scanners or tractor tracking devices. The information is processed via machine learning algorithms, and then we automatically push them via APIs to mobile apps, and that mobile apps, the recommendations are executed by humans actually. So far, we call this human-machine interaction Bionic Agriculture, okay? In the upcoming 5 to 10 years, we are going to witness that the entire process will be handled by machines actually. Like the recommendations will be uploaded directly to robots that can be a tractor with a plantation machine, or that can be an automated irrigation system. And all activities will be executed by the machines. Agriculture will turn into an industry close to how to say it, sorry, like land management, or I can't find the English name, sorry for that. So real estate management, something like that. You have an asset and you have some automated systems to better create cash flow from that asset. And everything will be done by machines. So basically, we have been in this industry for 10 years, and so far we served more than 250,000 farmers. We are serving mostly international corporations like agri-science companies, which I will show in a minute. We monitor daily more than like 250,000 hectares every day. It's roughly 1.15% of total Turkish arable land. So far, we have installed more than 500 IoT devices. By the way, the number of devices we are installing to the fields are growing exponentially. Probably this number will be, by the end of 2022, close to 2,500 or so. And we have executed this year 13,000 digital soil analysis, which is roughly one analysis in every 8 analyses are executed in Turkey. As I mentioned, mostly we serve corporate clients rather than individual farmers. Via corporate clients, we are serving farmers. And among our client portfolio, like there are familiar names like Syngenta, Corteva, Bayer. These are multinational agri-science companies who are selling like seeds and crop protection products. But on the other hand, we also serve some tractor players or mechanization players such as New Holland, or food processors like Cargill, Tat, or Döhler. So our company is organized under three distinct business lines. Today I'm not going to go through all of them. I will just explain what we do about better managing irrigation and climate-friendly agriculture and sustainable agriculture. But we have three distinct business lines. The first is the IoT services and devices. The second is the APIs. The APIs are, for example, you are a retail bank focused in the agricultural industry, and you have a dedicated app. In order that app to be relevant and updated, you need to have content, and we are providing that content, like crop prices or like agricultural news or some additional tasks. The third one is the digital market intelligence. This is basically satellite-backed crop identification and crop identification service, but based on whenever you identify the total plantation of area of specific crops, you may improve that data with additional data sets, and you can plan some macro strategies based on your plantation areas. I will explain actually towards the end of the presentation. So basically, we have four off-the-shelf products, but today I am going to explain only two of them. But with these products, an individual farmer can easily manage his or her whole farming operations. So he can decide on fertilization program, manage irrigation, manage fungal diseases, manage pests on the crop, and also inspect what's going on the field on daily basis via satellite images. The first device, we call it Filiz, it's in English Sprout. It's a brand new way of approaching climate sensor design, because most of the sensors you probably have seen has solar panels, some cables on them, and requires professional installment. So we designed this device out of scratch, and with some basic design aims. That the first aim should be like, it should be easily installed by farmers. It should have a lean design, and it shouldn't have any cables around or no solar panels. So therefore, we have used the latest communication technology here, narrowband IoT, which enabled us to design a low power device, which can be powered by two powerful batteries, and which lasts like at least 3 seasons, with hourly data submission on the field. And with this device, actually, it has a dedicated data collection. So it has some machine learning algorithms to provide the irrigation advices or the fungal disease warnings. But it also has a dedicated app where farmers easily manage their irrigation and fungal disease management activities with this device. And also, one of our design principles was like to produce a very pricely competitive device. Actually, the competition is 2 or 3 times higher than our price. Usually, the sensors which require professional installments starts from 2,500 euros and will go up to 5,000 euros. Here, our device has a retail price of 950 euros only, with all the sensors which are included in the expensive devices. And it has a very basic design. And so I can skip this. Okay, the second off-the-shelf service is, by the way, whenever I say off-the-shelf, you can order these devices. We are sending them in a couple of days, and you will be using them like in a week or so. This satellite health monitoring service can be activated within a matter of hours, actually. What we do is in order to be a good farmer, you have to have two capabilities. The first capability is technical know-how, how to grow corn, how to grow apples or tomatoes. So you have to have that know-how. But the second capability is inspection. So on daily basis, like on frequent basis, you have to go through your fields and understand the progress of your crop, whether it's going on track or not. But based on human capabilities, it is impossible to 100% inspection on daily basis. Usually what happens is a farmer visits his or her farm, maybe twice a week in the best case, and he or she can only inspect 2-3% of the total planted area. Here, I mean, we inspect instead of farmers via machine without mistake 100% every day. So it's roughly like 140 times better inspection than a human being. And what we do is we enable farmers to manage their operations from remote locations. For example, you live in London and your farms are located in the northern UK, but you have a steady team on your farms, attending your farms. And from your office in London, you can check daily specified information via our app. And you can assign tasks. These blue dots are digital flags. And the digital flags can be inserted in problematic areas. Here you see our inspection map. It's an easy way of representation of problematic areas. And from your remote location, you can assign this task to your field team. They visit those locations, take those pictures, and send them back to you. You will be notified via app. And you can either forward that information to your agronomist. He or she can live overseas. And they execute the diagnosis and you tell what to do to your team, and without even visiting your farm personally. And that's, imagine that's only one farm basis. Think about possibilities which we are delivering to our corporate clients who are having contract farming operations. Like you are managing 1,000 different farms, and we are prioritizing actually which farms to attend by their field team. If you have 1,000 fields, without these systems, you have a steady plan of visiting farms every 3 weeks. But what we do is you don't have to visit these 1,000 fields. Only 55 of them has to be visited in the upcoming 3 days. And whenever you go these 55 fields, these specific red plotted areas are important areas. Just visit them. Okay, so it brings great efficiency if you scale, if you manage large scale operations. By the way, this service also, I mean, we are working on a new algorithm where we are going to be providing irrigation deficiency based on satellite images, and we will be providing irrigation solution via satellite images as well. So I am skipping the APIs. Our third business line is digital market intelligence. In this business line, we have a team of really extremely talented 8 people. And we have been working on this issue for 5 seasons now. And what we do is we can identify many different crops, 31 different crops. This remote sensing and crop identification is actually, it's been around for 20-25 years, but usually it can be done for cereals. By cereals, I mean wheat, barley, or rice, or corn, those kind of crops. Identifying these crops close to the harvest time, it's easy because they have some distinct features. Because they dry out, their green color turns into yellow, and you can identify them very easily. What we do is, and those can be identified by basic decision tree approaches. What we do is we either mobilize machine learning or deep learning algorithms, and we can differentiate between crops 6 or 7 weeks before their harvest. So without these distinct features are appearing actually. So that information is much more valuable than identifying crops at the end of the harvest season or after the harvest season, because our clients can act upon the data which will impact their procurement strategy at the harvest. So they will have 6 or 8 weeks time in advance to decide on their procurement or origination strategy during the harvest. What we specialize in is actually we are quite strong in legumes, which are like the new important crops, because like the macro trend currently is replacing animal-based protein into plant-based protein, and lentil, chickpeas, peas, and beans will be the major source of plant-based protein. Therefore, like how much plantation area is in any given season on the world is extremely important, and it has some commercial value. On the other hand, high value crops prices are extremely volatile, because these crops like tomato, potato, or onions, their yields are too high. Like when you go to a cereal, like a wheat field can produce either 5 tons per hectare, or in Turkey, usually the average is 3 tons per hectare. In wet regions of Turkey, like Thrace, it's like 5 to 6 tons per hectare. But in UK, it's like 8 to 9 tons per hectare. But if you go to tomatoes, I mean, it's like 90 tons per hectare. Okay, so with little plantation area, actually, you can end up with too much production. And only 5 to 6% differentiation in the plantation area may result in an excess capacity of 10 to 15%, which will have an impact of 20 to 30% on the prices, which we are always witnessing or seeing throughout newspaper headlines. The tomato prices have been rocketed or fell down. Okay, so therefore, identifying high value crops has extreme commercial value into that. How we can identify? We are quite strong in, and we can identify them in anywhere in the world, but what differentiates our company is wherever we go, our team quickly can calculate how much training data has to be collected. So for machine learning algorithms, you have to collect training data. Okay, we can calculate it in a correct way. And we have a dedicated tab to collect these training data sets. So a person using our app can collect like 250 to 300 points, where a person without an app can collect 25 to 30 data points. So that enables us to collect training sets 10 to 12 times faster than our competitors, and execute or deliver these results in a price competitive and fast way, actually. I mean, I want to explain actually, once you identify the crop map of any given region, for example, in Turkey, in part of Turkey, there's a region called Karacabey, where we also have some large-scale horse farms of TİGEM. And in that region, there are 21 different crops are grown. Okay, once we identify different crop types, we match them with climate data. On top of that, we match them with some evapotranspiration algorithms, and we can calculate the total region's irrigation requirements. And that data can be matched with the water supply in different either rivers, lakes, or specific dams for irrigation. So within the season, we can tell whether there is enough water to irrigate all these crops or not. And also, like, we can run some simulation models, like assuming, okay, let's keep the, sorry. I am sorry. We can run some simulation models to imitate, to calculate what will happen if the average temperature in anywhere in the world goes up 2 degrees, 3 degrees during summer. And we can calculate the total water budget in those scenarios, actually. I mean, based on that scenarios, actually, a country can decide on what kind of investments they can do, like whether should we invest into a solar waters like desalination facility, or should we invest into drip irrigation systems rather than using like flow irrigation methods and so on. I mean, in a nutshell, that's what we do related to the climate friendly agriculture. If you have any other questions, I am more than happy to answer them. And this is a screenshot of our crop map platform. You can visit cropmap.com to understand what kind of services we offer based on satellite crop identification. Thanks a lot.
We will continue with our second panelist from the United Kingdom, Mr. Ravi Joshi from Adra Systems Limited. Mr. Joshi is one of the company directors with vast experience in the fields of agriculture, electronic research and innovation, together with marketing and branding in various parts of the world. Adra has developed a system that senses moisture in the soil and fields automatically. It is designed for gardens, landscaping projects, and farms can be integrated into existing irrigation systems. Adra Smart Water Management System focused on serving landscapes, agriculture, horticulture, and sports field industries in conserving water. Mr. Joshi, please, the floor is yours.
Done. Sorry about that. I'm just going to share my presentation. Can I see the presentation? Hello, can you see and hear me now?
Yes.
Can you see the presentation?
And can you see the presentation? Yes, it works very well.
Okay. As the lady said, I'm Ravi Joshi from Adra Systems, and we are into 3 different productions of products. We have got 3 main lines of productions, namely into water conservations. And hang on, just a minute. I'm a little bit. can I have this thing here? Oh, what do you want? Just over here so I can put the whole thing here. This is going all over the place. This is how the presentation is done. Yeah. Okay. Other systems has got 3 lines of productions. First one, which is called smart controllers for major irrigation systems, where our systems are laid in any type of irrigation, not just one particular ones. And second one is called air monitoring system for the particulates, nitrogen oxide, carbon dioxide, and which are all in relation to COP26 now. And I'll start with the irrigation system, basically. What irrigation system basically does over here, in this system, we don't just rely on the hardware side of it. We also relate into the satellite imagings and so forth. But we do not give the burden onto the farmers to say that you're going to go and study on our systems or vice versa, learn absolutely everything about our system. So we have the algorithms on the ground and also with the satellite to say that, okay, if the farmer requires certain foods of crops, whatever it is, in a certain percentage of moisture in the ground, the system will automatically work in conjunction with our sensors in the ground and the satellite, that how the things are developing there. I will go a bit more in depth afterwards. And the air monitoring system, we have the analytic reports for whether it's in a small house or a office or in a very broad area into what would you call a municipal area. So we have 2 things over here, which is basically looking into nitrogen oxide particulates, and we also have for the humidity, temperatures, and we have all these systems are solar powered and can be used with the grid if it is available. And the air monitoring system can be used indoors as well as outdoors. The third one, our system, which I'm going to be going in depth in all of them, is our planter system, which basically what we do is the carbon in the air, we take it back into the plant and have it stored over there. And in process, we extract a pure air, or rather more of an oxygen air. So this can be used indoors, outdoors, whichever way you want. Planter is just an example, but we can also have it done on a large scale into the streets as well. The smart watering system, which is basically in 2 different models. The basic model, and when we also have the GSM model. Now the difference between this is basically to give a farmer a more flexibility in how to irrigate their farms in a process to get it absolutely to the point where they can economically make an investment into the system. Our systems, on the other hand, we in competition with our competitors, we are far more cheaper and we are more giving information, and it's easier for them. The system in particular is like, this is a typical example where the system basically has got different sizes of valves and the charging points, and all of them are on a solar panel. And the way we are doing is having a sensor in the ground, which basically correlates to our main controller system and goes into the satellite. So for example, we have a situation that, we analyze a situation that we are not going on a timer based, we are going on a sensor based. So if the plant requires water, the moisturity, then it basically asks for the water, but then we are evaluating, looking at the weather and the satellite side of it, if there is a rain approaching there or how long it's going to be or whatever it is, the system calculates its time there, and then it lays out the information to the ground to say that, okay, you can either sustain it for a while. We give that leverage to the sensors for between 2 to 5%. And in process, what happens over here, like in UK, we have a situation that, just a mile apart, we could be having a rain on one side, on the other side is absolutely dry. So if the farm happens to be on the dry side, we are still calculating. And if the satellite says that, there's rain approaching and the ground is still dry, the system takes over. And basically there is a moisturity induced into the soil so that the farmer and the product does not suffer into the economy. The characteristics of these both models are basic model and the GSM model both of them are more or less standalone control units. There you can basically take them anywhere you want. And it's the GSM model is an IoT based. The basic system can be programmed into the field, while the IoT is app driven through smartphone, computers, iPad, or whatever medium you choose. The basic system has got 30 zones to control. So a farm can control 30 zones. But generally speaking, our clients are in the African region, South American region, and also into the European region. Sometimes they don't require 30 zones. With the basic model, we also offer them that, if there is a cooperative of small farmers, we can bring the one system to work on 30 farms, and that will do the job. While the IoT is more than 30 zones, and it only controls one area. The information on the controller are always there to show the farmers what is happening. Zones programmed per unit. So a sensor and a valve, whatever it is required there, they can be programmed individually. So the water is related to that particular zone, in which case you could be having part of a farmer absolutely damp in water, or the other one is on a dry area. So we can control individually all the areas. On the IoT, it is programmed for remote units only. Both of them are power driven or the solar driven, and the analytic data is not available on the basic model because the controller will be giving the reading all the time. And while the IoT will have the history on the analytics. Now, these are the apps over here, which is remotely monitored by IoT devices. You can have multiple sensors. You can still observe them there. And you can also view the analytic data, which is available on the app. This particular area, it was in a participatory city arena project, which was in a local area over here. And our system was initially tried over there to see, what difference can we make. And you can see in the photograph that, it's very much a dry area, and people used to basically come in to water the plants, and the growth was not appropriate. So what we did was this is the first phase, you can see even the plants are struggling. This is a system we installed over there. And what we had was, the outcome was that, which is the plants were growing absolutely on automated basis, and they were growing quite happily. And to our astonishment, we also found that certain fruits and vegetation needs to be looked into very carefully, where our sensors were doing all the jobs for them. And certain fruits like, blueberries and apples, they were growing quite happily over there. Our air monitoring system is now used by various customers, and it's been endorsed by our UEL, which is a University of East London. And we are in comparison with our competitors, and we have basically got into them to say that, okay, this is the area where air monitoring system has to happen. And that can be indoors, outdoors, whether it's an office or it's a commercial area, it will give you the information there. While in coming to the planter side of it, the part what we are doing basically over here is getting all the anomalies, or rather getting all the carbons out of the air back into the soil for the plant to thrive on it, and extracting a cleaner air. Now, as per our COP26 predicament, or rather their suggestion was that, we need to clean our air very, very fast within next maybe a decade or two. But I would say that instead of doing deforestation, we go into reforestation, whereby you can grow the plant inside, outside, wherever you want to grow, and we will help the Mother Nature by extracting more cleaner air than putting out more carbon, because the human behaviors is not going to change within a decade or two. It will take quite a while time, but in time we can do with the technology is get the air much more cleaner. Even if we make a percentage difference, it is a lot. Thank you very much. I hope you enjoyed the presentation. Thank you.
Thank you, Mr. Joshi. Now I would like to proceed with Ms. Selen Doğru. She is the only female among our speakers today, so I can make positive discrimination in her favor. She may speak a little bit longer than gentlemen. Selen Doğru is the board member of Doğru Çiftlik, Doğru Tarım, and graduated from La Roche University, Spain, BBA in Tourism and Hotel Management, and today, finally, she is today's farmer. Doğru Tarım has been established in 1910 in Adana Karataş by Müslüm Doğru. Today, Doğru Tarım is continuing with fourth generation managers to maintain and develop the product quality in dairy products, being one of the leaders in the market. Dear Selen, the floor is yours.
Thank you so much, Ms. Erbuğ. I would like to share the screen, but there is a technical problem, so I cannot open it in a full screen. Can you see the presentation?
You do?
Yes, Selen.
Yeah, you can see the presentation, right?
Yes.
And me as well. Okay. So I cannot open it in full screen because I would like to share a video with you as well. So, yeah, I would like to talk about the history of our farm. As Mrs. Erbuğ said, that it was established in 1910 in Adana Karataş, and it's a spiritual heritage from our grandfather, Müslüm Doğru. And I'm really proud to say that I am the board member of Doğru Farm as a fourth generation. And I would like to talk about our work. Nowadays, the company is working on field agriculture, horticulture, and animal production. The field production is based on alfalfa, corn, and other grain groups and forage crops. And on the other hand, our farm is generating 27 different types of citrus in agriculture. Over the years, Doğru Farm has expanded, and in 2011, the company has implemented the breeding dairy farm project in Adana with the capacity of 2,000 cattle. And with the realization of the project, our company started with 200 cattle in the facilities. Nowadays, our capacity has been reached 10 times bigger compared to first day with love, faith, and effort. Today, our company, which meets the animal needs of many breeders in different parts of our country and continuously responds to the citrus needs for export and domestic consumption. And in my second slide, I would like to show you a video of my grandfather, Cumali Doğru. He's my inspiration, and he will be talking about the water technologies and our farm in the video. Can you see the video?
Tarımla yoğrulmuş insan hikayelerini Yaşar Kemal'in, Orhan Kemal'in romanlarından okuyoruz, biliyoruz. Ama işte o hikayelere ortak olmuş, şahit olmuş çiftçilerimiz de var. Onlardan bir tanesi yanımızda, Cumali Doğru. Hemen arkamda görüyorsunuz Çukurova'nın bereketli toprakları var. Ne ekerseniz, dikerseniz fazlasıyla veriyor. İşte bu toprakların biraz da biz tarihini konuşalım istedik. Tarımın hep bugününü, yarını konuşuyoruz ama dünü nasıldı? Onu Cumali amcadan alacağız. Cumali amca, kaç yaşındayız?
80 yaşındayım.
Maşallah, Allah uzun ömür versin. Sağlıklı, mutlu, huzurlu. Şimdi seninle ben biraz bu bölgenin özellikle, evet, hem de gerçi Türkiye'nin tarımı, geçmişini biraz konuşalım istiyorum. Yani bundan şöyle bizi bir 50-60 sene önceye götür. Bu bölgede o zamanlar ne yetişirdi, ne ekilirdi, ne dikilirdi?
Efendim 50-60 seneyi geride bırakalım. 20 yıl evvelinin tarımıyla Çukurova'da bugünün tarımını mukayese bile etmek istemiyorum. Mukayese ettiğimde şöyle etrafıma bakınca kendimi rüyada bulunduğumuz arazi 400.000 dekardır. Buradan söz edeceğim ben. 400.000 dekar. Bizim Çukurova'nın doğusundan Ceyhan Nehri, batısından Berdan Nehri, tam ortasında Seyhan Nehri geçer. Ve kuzeyde bizim 3 tane barajımız var Seyhan Nehri üzerinde. Yine Ceyhan Nehri üzerinde de barajlarımız var ve Berdan üzerinde de var. Bu kadar dünyanın en verimli topraklarında. Şimdi Çukurova'ya baktığımız zaman dünyada 3 ova vardır. Çukurova Türkiye'de, Amerika'da Kaliforniya, İtalya'da Po Ovası. Herkes turistik yerleri gezer. Ben Avrupa'ya sporculuğumdan beri giderim. Daha sonra da giderim. Gitmeye başladım. Ve buralarda ilk gezdiğim yerler tarlalara bakmak olur. Herkes otobüste başka yere bakar. Ben tarlalara bakarım. Ve genellikle de orada gördüğüm, benim memleketimde de niye yok derdim. Dünyanın 3. verim bakımından, sulama bakımından, iklim bakımından dünyanın en nadir yetişen ürünleri Çukurova'da yetişir. Fakat ben o zaman Çiftçiler Birliği Başkanıydım. Ömrümün 18 sene Çiftçiler Birliği Başkanlığı yaptım. 18'ini de bu 400.000 dekar arazinin ıslah edilip Seyhan'dan geçen suların buradan da istifade etmesi için uğraştım. Şu gördüğünüz arazide pamuk olmazdı, mısır olmazdı, buğday olmazdı. Olmadığı için çorak bir araziydi ama su var. Şurada Seyhan Nehri var. Seyhan Nehri'nden su alırım düşüncesiyle ben burada 5.000 dekar çeltik ektim. Ve burada emeğim çok. Bu arazileri kiraya tutardım. Kendi arazimin dışında onlara da çeltik ekerdim. Tabii sulama olduğu için devamlı burada bir ıslah oldu. Ömrümün yarısını dedim buraya verdim. Şu bahçeler hep damlama sulamayla yapılıyor. Ve bu bölgede ilk defa damlama sulamayı ben yaptım. Bu nasıl iştir böyle şıp şıp şıp damlamayla ürün mü meydana gelir diye hep etraf köylerden geldiler gözler. Çok eskilere gidersek 50 yıl dediğiniz zaman traktör yoktu. Bizim işletmeye ilk defa traktör girdi 1946'da.
1946 yılında ilk traktör.
1946 yılında demir tekerlekli, hidroliği yok, bir şey yok traktör. Ve etraf köyler hep traktör nasıl diye gezdiler. Köyün içerisine çıktığı zaman ben de çocuktum. Ben de Tuzla köyü doğumluyum. Traktörün arkasından koşardık. Bu nasıl şey kendi kendine gidiyor diye. Yani oralardan buralara geldik. Önümüzdeki süreçte her şeyin çok daha iyi olacağına inanıyorum. Türkiye büyük bir devlet. Çukurova çok verimli bir ova. İnsanları çalışkan. Yeter ki devletimiz bize pazar bulsun. Hamdolsun onu da yapan çiftçilerimiz var. Şimdi ihracatta yetişmiş dünyanın her tarafına narenciye satan gençlerimiz var. Biz de inşallah ileri programda bu işi 4. nesil olarak ben 2. nesil temsilcisiyim.
Şimdi tam onu soracağım. Babanız bu işe başlamış ilk çiftçi ama sıfırdan başladı dediniz. Ne vardı elinde?
Efendim babam tabii Tuzlalıdır. Ben de orada doğumluyum. Babamın okuması yazması yoktu. Annemin de okuması yazması yoktu. Sıfırdan başladı dediğim yani bir dönüm arazisi yok. Bir dönüm tarlası yok. Ama çok çalışkan bir insandı. Güçlü kuvvetliydi. Yazları köyde iş olur. Her türlü işi yapar. Yani sıvacılık yapar, duvar örer, her şeyi yaptı. Kasaplık yapar, bahçe yapar. Entegre bir tesis yapmış köyde. Ben o zamanı bilmiyorum. Bir tarafında kahve, bir tarafında fırın, bir tarafında gitmiş Urfa'dan koyun getirmiş. Kasap orada keser, eder. Annem de tabii yardımcısı. Yani annemi konuşmadan olmaz. Babam kadar da annemin bu işletmede şeyi vardır, emeği vardır. Tabii bu işlerden kazandıkları paranın bir tek kuruşunu harcamamışlar. Biriktirdikleri bu parayla köyde tarla satıldıkça almışlar. Orta ölçekli bir arazi durumuna gelince diğer işlerin hepsini feshetmişler. Çiftçiliğe başlamışlar. Babamın sıfırdan başlaması dediğim hiç arazi yok. Koşullar çok zor. Kıt imkanlar ama çok çalışmış. Ama ne kadar çalışırsanız çalışın, ne kadar para kazanırsanız kazanın, ille de tasarruf. Tasarruf etmesini bilmişler. Ben babamdan en az 100 kat daha iyi şartlarla bıraktım. Allah nur içerisinde yatsın ikisi de. Tabii benden sonra gelen nesil de bayrağı yere düşürmedi. Her gelen bayrağın yükseltti direğini. Daha şimdi 4. nesil bu işe hazırlanıyor. Karşıda gördüğünüz 2 yavrum, ikisi de çok çok iyi, benden daha iyi tahsil yaptılar onlar. İnşallah artık onlar da yurt dışında bu işi büyüyerek taşıyacaklar.
Yeah, I guess you have more information about our farm with the video, and I would like to talk about the water technologies in agriculture as well. 70% of the freshwater resources are used in agriculture. Unfortunately, with the global warming, these resources will be decreased in the future. Because of the fall of the water resources, the water saving must be must be more in agriculture. The developed countries are using irrigation systems such as dripping, linear water system, and pivot. These systems help us to save more water and increase the productivity of agriculture. And in my opinion, the government should implement underground pressured irrigation pipe projects. Thus, it will help to save water and energy in agriculture, and purifying household wastewater and using it in agriculture will gain importance in the future. And I would like to talk about what we are doing in our farm. Our farm was one of the first companies that implemented the dripping irrigation system in 1992. We are using the system in all of our citrus farms, also with the help of soil leaf moisture measuring devices and meteorology stations. We have the opportunity of knowing the need of water of the plant and irrigate it based on demand. Our farm is also using pivot irrigation system that is based on 800 dekar with the wing length of 460 meters. This facility gives us the productive opportunity of irrigating and fertilizing the silage plants. And in the other slide, I would like to show the pivot irrigation system as well. This is how it works in our farm. And I would like to end with an important thing that I would like to mention. Today it's Teachers' Day in Turkey. So I would like to first thank our head teacher, Mustafa Kemal Atatürk, and all other teachers. And especially I would like to thank my grandfather, my father, and my uncle. We are working together. And they are my teachers in this job, and I'm really thankful of learning their experiences and making our job in a better way. And I put my email address as well here. I know there's a question and answer part, but if you have any further questions, you're more than welcome to send me an email. And thank you so much, Mrs. Nurdan Erbuğ, for helping me to participate in this webinar. Thank you.
Thank you, Selen'cim. Such an insightful presentation that showed us a very good example of technology application in dairy business. Finally, we will end our panel with a striking example of successful use of technology to reduce environmental impact and maintain efficiency in agriculture. Mr. Ray Long, Managing Director of Excel Bio Company, United Kingdom. Mr. Long has extensive experience in biotechnology, and Excel Bio is a unique bioenhancement technology. It is a 100% natural biological accelerator which consists of microorganisms, micronutrients, etc., which greatly increase yields without using chemical fertilizers. Mr. Long, please, the floor is yours.
Thank you. Thanks very much. Good afternoon, everybody. I'm just going to share my screen. Now I need to find my presentation. Okay. Okay, so our company, XL Bio, over the last 20 years has developed a 100% natural biotechnology to increase root structure, to work with many applications wherever there is a biological process. So the technology is based on a microorganism, the oldest in the world, from the Archaean species, and it's been around for 3.6 billion years, so, and still working very well. So the actual, we call it a Crenarchaeota, but the difference between bacteria is sensitive to pH, temperature, and salinity, whereas our microorganism is pH tolerant, 1 to 13, salinity tolerant, biocide tolerant, and temperature tolerant. So how does it work? Well, it works in syntrophy with bacteria, and through a transfer of what we call coenzyme A to the bacteria, which is like a steroid for the bacteria, which increases its activity in biological process. And also the bacteria transfers back to the archaea waste matter, and this extends the cycle of the bacteria and makes everything run very efficiently. The applications are numerous, as you can see. We can treat poultry through drinking water, which increases egg production and reduces feed. Hydroponics, vertical farming. We've got many case studies where you can see the increases in crop yields, groundwater decontamination, lagoon, natural lake restoration, feed line for livestock, where we've successfully treated cryptosporidiosis. And we can remediate manure, and also our technology helps to improve the condition of the soil. And this is a residual condition, so the soil becomes more susceptible to holding water, and which means that you can use less water, and also virtually eliminates the use of chemical fertilization. We produce on-site the liquid, activated liquid, you can see here in a small simple container. So we provide the cartridges, which are made from the same material as tea bags and coffee bags, and our media is inside. And when we heat the temperature up to 28 degrees, we start to release and reactivate and rehydrate the XL Bio within the cartridge. So this is easily put onto any site. We just need a mains power. Maybe in Turkey we don't need that. And we control the flow depending on the application. So it's quite a simple operation to operate. It means that you have to check the water flow and every week replace the tea bags, or cartridges as we call them. So it's a very efficient process. We did some experiments in Switzerland by adding with the compost our material, our XL Bio, and in the two trays you can see the leaf growth, and this was over a 30-day period, and in each pod we had like for like. So here, if we had watercress, we have watercress here, and likewise. So after 30 days, we emptied the pods to look at the main function, which is to increase the root mass. So here you can see a like for like, that is with the XL Bio. You can see very clearly the difference in root growth. And obviously, if you're increasing root growth, you're increasing the uptake of nutrients, which then gives us a very good, effective increase in yields in any crop. whether it's in the soil or in vertical farming or hydroponics. So here at our facility, we harvest the material in South Africa. This is at our production plant. And my partner is a keen gardener. She did a lot of trials. And on the left, you can see a vine which was planted and the same cultivar as the one on the right. And they were both given the same watering protocol. And you can see the difference in the growth of the plant. And it's quite amazing to see. The same applies to trees. Here we treated some trees in the pots 6 months prior to planting in the ground. And the small trees are obviously without, and the larger trees are with XL Bio. So it has many, many applications. As I said, in obviously tomatoes, cucumbers, virtually any plant that has a root structure, we can increase the root mass. It also helps to eliminate funguses, and as I said, reduces the need of fertilizer, chemical fertilizer. In egg production, you can see here a typical growth or increase in yield with eggs. Roughly, on average, we find that we increase the yield by 4% and 8% reduction in feed costs. And that's quite standard. In a farm that we're running at the moment in the UK, we've actually had, according to the farmer, an 18% reduction in feed costs, which we're not too sure if that's exactly right, but he's a very happy farmer. So, as I said, many applications. How it works with any livestock is as they ingest the XL Bio in the drinking water, it stimulates the gut flora and maximizes the efficiency of the gut. Therefore, the chicken or cow, whatever it is, needs to eat less. And we maximize the increase in the eggs and reduce what we call leakers, because also the chicken produces more quality eggs that don't leak, and so therefore there's very little wastage. So for all the applications, we are basically looking for a licensee or licensees within Turkey, ideally an established company already operating in supplying farms or installations of vertical farming or whatever. And then we will train that licensee in all aspects of our technology and provide ongoing technical support. I haven't put my email address there, but I'm sure you can find it. And you can also look at our website, which is www.xlbio.co.uk. So I would have liked to have spoken for longer, but it's quite an involved subject. But I will be happy to receive any inquiries from you. And thanks very much for your time.
Thank you for your impressive presentation, Mr. Long. Now we have some time for questions. If you have any questions, please write them in Q&A section in the menu. Mr. Aycan Damalı from DEİK will be reading the questions to our panelists.
Nurdan, the first question is for you. Professor Dr. Yavuz Öztürkler would like to know if you can talk about how many kind of sheep breeds embryos do you import?
Dear Professor Yavuz Bey, I think we have so far imported Dorper, White Dorper, Romanov, Texel, ovine embryos, and Holstein bovine embryos.
Okay. thank you. We don't have any more questions, but some companies shared their information in the chat box. So if you would like to see that, please check the chat box for information, contact information for various companies. Başka sorunuz var ise Q&A ya da chat'e yazabilirsiniz panelistlerimize ya da bana daha sonra da gönderebilirsiniz. Sanıyorum yok Nurdan Hanım.
Peki kapanış konuşmasını başkanımızdan rica edelim. Osman Bey.
Nurdan, okay. Thank you very much, everyone. It's been a very insightful and informative webinar. Personally, I learned a lot. I'm not from the industry, but what I see and what I heard today was extremely interesting, and I wouldn't expect the technology to be that much interfered with the agriculture field, and I was positively surprised, and it was great to hear those presentations. Once again, thank you very much, everyone, for your time and presentations, and have a great day.
Thank you very much, Osman Bey. Dear Sait Bey, Turkish and British guests, thank you very much for joining us today.